Hello, sixth graders. Today we're going to be organizing probability and data with using tree diagrams. So watch closely how we're working with options and figuring out the possibilities and the outcomes here, okay? First of all, we have a breakfast order. Suppose members of the hiking club are served a breakfast bag wherever they have a Saturday morning meeting. Members use the form at the right to place their orders, okay? So you can have a beverage. You can have milk or water. You can have a bagel. You have plain or raisin, and you can also have a fruit, an apple, banana, or orange. So a person could have milk, plain bagel, and an apple, or milk, plain bagel, and a banana, milk, plain bagel, and an orange. We want to know how many possible different outcomes we could have with this order. Okay? So we can organize things in a table, just like this, or we can use a tree diagram. And this is how this looks, okay? And watch closely as we're working on this. So right here, the M and the W represent milk and water. The P and the R represent plain and raisin. So you can have milk and a plain bagel. You can have milk and a raisin. So milk has two options, just like here, two options. So water right here, we're gonna have to put in a P for a plain and an R for a raisin, okay? The next thing we have to add is the apple, the banana, and the orange. It'll be right here, apple, banana, and orange. So if you think about it, a person could have milk, plain, apple, milk, plain, banana, milk, plain, orange. So you'll actually repeat A, B, O, A, B, O, A, B. Not sure why that's not fitting on this page. O will be over here. Okay. Sorry, O has to be here. Sorry, it's off my smartboard. Okay. But so the O is over here off to the side. Okay. So you can see here, so you'll have milk, raisin, apple, milk, raisin, banana. So how many total possible outcomes are there? There are, to answer this question, how many different breakfast bags are possible? There's 12 different breakfast bags actually possible in this scenario. So you're going to be going milk, plain, that's an option. Milk, plain, banana. Milk, plain, orange. Water, plain, apple. Water, plain, banana. Water, plain, orange. Here's all your scenarios, okay? Let's take a look at this question. It says, suppose 60 members fill out an order form. About how many people would you expect to order milk and plain bagel? So we have 60 possible options, okay? So go out of 60 options, okay? Just milk and plain bagel. So we're not even getting down to the fruit, okay? So if we're just going here, we have one option, two options, three options, four options, okay? So how many people would you expect to order just milk and a plain bagel? So out of the 60 people, we have to divide 60 by 4. 60 divided by 4, because only 1/4 is our option here, and we get a 15 here. So how many people? 15. Because if you think about it, 15 people will pick this, 15 could pick this, 15 could pick this, and 15 could pick that, okay? So that's how we're going to break it down. I know it's not as equally as an outcome, but we're just going to just pretend that it's the same outcome. Take a look at this next one here. It says, suppose each of the 60 members brings 2 guests. So if they are each bringing us, you have the 60 members, and if they each bring 2 guests, you're going to be going 60 times 3, which is 180 people. Okay, you're going to have 180 people at this place. But how many people would you expect to order water, raisin, and an orange? Well, let's take a look here. We're going water, raisin, and orange. Water, raisin, orange. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 options. So out of this 180, we have to divide it by 12. Well, 12 goes into 18 once. 12 times 1 is 12. Subtract, get a 6, bring down the 0. 12 goes into 60 5 times. 12 times 5 is 60. Subtract, I get a 0. 15 people would also order that. And some of you are wondering, how can that be 15 and the other one's 15? Well, if you take a close look, here we only were going to this option, so there's only 4 possible options, and we're dealing with 60 people. Once we lowered it all the way down, how about this? I'm going to try this one with you. Let's say we have 180 people. How many of them would pick no, I have time out. Let's say we have 60 people right here. Let's go with 60. How many of them would pick this option out of 60? So if we have 60 people, how many of them would order water, raisins, and an orange out of 60? Well, you have 60. You're going to have to divide that by 12. So only 5 people would pick that option. Because if 5 all picked each one of these options, that would equal 60 altogether. Okay. Now you're probably wondering, what did we do with this table back here? This table right here goes like this: milk, plain, apple. All it is this: milk, plain, apple. Go back. Milk, plain, banana. Milk, plain, banana. So the next one would be milk, plain, orange. Milk, plain, orange. Then it would be milk, raisin, apple. Milk, raisin, apple. Milk, raisin, banana. Milk, raisin, orange. Over here, water, plain, orange. Water, raisin, apple. Water, raisin, banana. Water, raisin, orange. Those are all 12 of your options, okay? You'll be working with several different problems like this today in your math journals, but simply it's just a way to organize data and break it down. It's pretty fun, and it's kind of nice to understand. So you have to take a look at what the question's asking, and then use your table to help you solve it, okay? Hopefully this helps. Nice short video today. I look forward to working with you in math today. Good luck.